The purpose of this video is to teach you how to identify rotations that will map a given polygon back onto itself. Recall from your knowledge of transformations that we say that a figure is mapped onto itself when the transformation or the sequence of transformations results in the pre-image of the transformation. In other words, where we end up after the transformation has occurred is exactly the same as where we started before the transformation occurred. All right, let's go ahead and take a look at the first example. In number 1, it says, identify the rotation that will map the figure onto itself. In looking at the picture of this rectangle, they very nicely identified the center of that rectangle for me. I know that because the length of the rectangle goes horizontally and the width vertically, and those two are different, that if I rotate it 90 degrees, I'm not going to map onto itself. In order for that figure to perfectly coincide with where it started, that rotation is going to have to be 180 degrees. So I know that my rotation is going to have to be 180 degrees, either clockwise or counterclockwise, it doesn't matter. But also recall that when we identify a rotation, we need to include not only the number of degrees, but also the center about which that rotation, or the point about which that rotation occurs. So we want that rotation to occur about the center of this rectangle, or in other words, the point whose coordinates are 2, 1. So again, big idea here is that we have to identify the point about which we're going to rotate the figure and the number of degrees that we're going to rotate it. Now, when we're looking at regular polygons like we are in number 2, it's understood that the point that we're going to rotate around is going to be the center of that polygon. So it asks us to list all rotations between 0 and 360 degrees that will map the regular octagon onto itself. And in order to figure out this question, I'm going to think about this regular octagon as a series of isosceles triangles. So if I break that octagon into a series of isosceles triangles, that octagon can be broken up into 8 triangles. Now I know that in one complete revolution, I know that octagon is going to have to go 360 degrees. So to figure out how many degrees will carry that green vertex onto that red vertex, what I'm going to have to do is take the 360 degrees total and divide it by 8. So I find that a rotation of 45 degrees will map each vertex onto the next consecutive vertex. Now that said, all multiples of 45 degrees will also work, because if I want to move it 2 vertices away, I'm just going to have to turn it 45 degrees and then 45 degrees again, or in other words, 90 degrees. So what I'm going to do in order to account for all of these rotations is I'm going to list all multiples of 45 degrees that are less than 360. So when listing all multiples of 45 degrees between 0 and 360, I find that the rotations that will carry this onto itself are 45 degrees, 90 degrees, 135 degrees, 180 degrees, 225 degrees, 270 degrees, and then lastly 315 degrees. Example 3 is a similar question where they ask us to list all rotations between 0 and 360 degrees that will map the wheel hub onto itself. So once again, I'm going to consider the center of my wheel hub, and I need to figure out the number of triangles that that wheel hub is made up of. So there's 1 triangle, 2 triangles, 3 triangles, 4, 5, 6 triangles. So again, if I consider that one complete revolution or rotation is 360 degrees, and I want to divide that evenly up amongst 6 triangles, I find that a rotation of 60 degrees will be sufficient to carry one of those isosceles triangles onto the other. So 60 degrees is the smallest rotation that will carry that figure onto itself, but I also have to consider all multiples of 60 degrees as well. So 60, 120, 180, 240, and 300 degrees. And then 60 more than the 300, of course, will carry it right back to its original starting point, but we wanted between 0 and 360. All right, so that's it on rotations and mapping a polygon onto itself. Why don't you go ahead and up at the top of page 7, summarize the key ideas and the important understandings, and then you can go ahead and see if you can apply your newfound knowledge to solve problems 2, 3, and 4 on page 7.